Hi, my name is Becky. I'm one of the instructors for calculus, and today we're talking about section 2.2, the limit of a function. So this title, the limit of a function, is a really boring title, but it's actually a really important topic. And what it really is talking about is what is the expected value and what is the unexpected, right? And so it's actually not quite as boring as they try to make it out to sound. We're going to take a look at some data from the coronavirus, which is a worldwide tragedy that has really highlighted just how vitally important it is for all of us to be able to read and analyze data and graphs. So this graph that we're looking at here is a screenshot that I took from the New York Times on July 17th, 2020, and it's showing the reported deaths from coronavirus by day in Massachusetts from the beginning of the coronavirus outbreak here in Massachusetts until the middle of July. And so what we want to talk about is the limit of a function. We want to talk about expected values versus unexpected values. And so the New York Times has highlighted in yellow this one particular day. It looks like June 1st. And so first I want to ask, what is the actual value of the number of deaths reported on that day, approximately, best you can tell from the graph? Okay, so we're just reading the data off the graph. It looks like a little bit less than 200, maybe around 190 or so. Okay, and now I want to ask, what is the expected value? If you didn't know yet, maybe you're coming up to the end of May and you're trying to predict how many people are going to die on June 1st. What's the value that you would guess is going to be the number of deaths for that day? Okay, and again, we can just read it off the graph, right? And so the actual values are going up and down. And so the New York Times has drawn in this model of a 7-day average. And from that, it's coming down, dips below 100 in the middle of May and keeps going down. So we would have guessed, right, the expected value is probably around 75, 60, something like that, right? And so that expected value in math is what we call the limit of a function. And it is a value that depends on the point, right? So our expected value on June 1st would have been around 75 or something like that. On May 1st, our expected value, right, would have been maybe around 150 or something like that. So you're talking about the limit of this function, how many deaths per day, at a particular point. In this case, we're looking at June 1st, where this yellow bar is. The limit would have been about 65, 70. We don't have an exact value. The actual value was closer to 200. Okay, and so when we look at this section in the book, the limit of a function, they're going to be working with very nice, well-behaved functions, or mostly well-behaved functions, so that we can better understand the ideas of the calculus behind it by having some nice functions. But I want you to keep in mind this real-life application, right? This is why we're studying these kinds of things.